Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, fruits into baskets. So the problem basically says that we are visiting a farm that has a single row of fruit trees that are arranged from left to right. And these basically trees represents an array of fruits where the number represents the type of the fruit, okay? Not the count, the type. So here, for example, we have fruit of type 1, fruit of type 2, fruit of type 1, right? And we have 2 baskets only, so this is the capacity we have, and each basket can hold only one single type of fruit, okay? But you can take as many as you can. And starting from any tree, which basically means starting from any positions in this array, you can pick exactly one fruit while you are moving to the right here, okay? And it must fit into the 2 baskets. So basically, but what this means basically is that, let's say you are here, you pick fruit 0, and then you can pick still fruit 1 because you have 2 baskets, but you can't pick 2 unless you remove one of these, because otherwise you have 3 types of fruit and you have only 2 baskets, and so you will need to pick only maybe 1 and 2 and leave 0, okay? Because you can also start from any position. And also it says here, once you reach a tree with fruit that cannot fit your baskets, you can't take it, right? So you can't take this 2. That's what I said earlier. And you need to return the maximum number of fruits you can pick, right? And so if we take a look at this a little bit here, for example, let's take this example. You take 1 first, right? And then you take 2. You have 2 types now, but now you encounter 3. You can't take 3 in addition to all of these. So you can take 2 and 3, however, and then take these 2, because you have a basket of this. And so this is the longest one because it's of length 4, okay? So that's sort of the idea of the problem. Now let's see how we can solve it. Okay, so let's say we have this array here. So what do we need? You can see here what we do actually. We just try here. Now we have 1, 1, and then we go here. We have on 2, we have 1. But now the keys, if we were to use, let's say, a map or a counter to keep track of this, we realize now that if we add 3, we'll have 3 keys, right? And that's more than the 3 keys, because each key we just keep the count. So we have only 2 baskets, and this will need 3 baskets. So this is not valid. So we'll need to remove one of them. And since we need to pick in a contiguous way, we have to do something like, we have to remove the one at the beginning of the window, right? And so you can see already what I'm doing here. This exactly looks like sliding window, and so that's exactly what we want to do here. Okay, and if you think about this problem a little bit and about what we did here, this problem actually just boils down to getting the max length, right, of contiguous subarray that has only 2 distinct element, right? Distinct element, because we have only 2 baskets, so we can only take 2 types, right? But we can take as many as we can. So for example, this window, 2, 3, this window here, 2, 3, 2, 2, this is a valid window because the types it has are only 2 and 3, and the length is 4. The other possible window is taking this 1 and 2. It has only 2 distinct elements, but the length is just 2, so this one is better. Even you can take this window if you want, starting from this one, but then this one is of length only 3. It still has 2 types, so it's valid, but it has only length 3, so 4 is the best one, right? So this is sort of what the problem boils down to. Now, how do we solve it properly? Well, just what I did here, which is the counter, that's what we need to do actually. So with sliding window technique, what you should do is think about a couple of things. So first, you need to think about how do you maintain your window, what data structure you will need to maintain your window. And then the second thing you need to think about is when do you move your window to the left or to the right, right? So when to move. of course, in most cases, because you are doing from left to right, you need to think about when to move your window, right? And in most cases, it's to the right. Okay. So these are the two things you need to think about. And so here for our case, to keep track of the occurrences and the number of fruits we picked, we need some sort of a hash map, or in Python you can use a counter, right? Because we want to know first how many types, and if a window is valid, we want to calculate the total length. So if we had 2 2s, we want to add 2 2s, right? And when to move the window, well, in our case here, we should move as soon as we find that we no longer have 2 distinct elements, that if we have more than 2 distinct elements. So if more than 2 distinct elements, then we should move. But if we still have just 2 distinct elements, then we should just move right. Okay? So here, still 2 distinct, just move to the right. Okay? Okay, so now let's apply this to this example here and just see what that will look like. So if we do that, then our window will need to be a counter, right? So we'll have 1 has, first we are here, has 1 occurrences, and we need to of course keep track of the answer, which is the max. Let's call it the max count, or yeah, maybe the best count, let's call it. Okay, so we need to keep track of our best count. Okay, and we need 2 pointers, one to identify the left and one to identify the right. So first our left and right are here, and so we have 1, and our best count initially is 0. Okay, and so when we each time, as long as the length of the window is smaller than 2, we want to update our best count. So here now the window size, which is the number of keys, is 1, so we assign best count to 1, and we move our right pointer, right? So we move our right pointer here, we counter 2, so we add 2 here, we have 1. Now the length, the number of distinct element is just still just 2, right? That's just the length of the keys here. So we increment our best count by 2 here, and then we move our right again here. But now if we move our right, we have the length is 3, so we need to remove the first one, which is in the left position. And so to do that, we just remove basically we just delete in our window map, we just delete the value on the left. Okay, and so we no longer have this, and now we have 1 3 and 2 1. Okay, and our count is still 2. And then we moved our left pointer, so our left pointer is here. Now we move our right pointer is here. We have another 2, but we still have the length of distinct element is 2, so we are still good. But the count changed because now it's 2 plus 1, so it's 3. We move our pointer again, right pointer. Now we have 3 2s, and then so the best count is 4. Okay, and that's pretty much it. We are at the end of the right, and this is 4. This is the max that we have, so we return this max. So that's sort of the idea. Pretty simple application of sliding window. Now in terms of time complexity, what you saw here is that we are just doing a linear scan, so it's O of n time. If you were to do this approach with generating every subarray in a brute force way, that will be O of n squared time. But with sliding window, we can get that down to O of n time. In terms of space, we are using this extra window map, so it's O of n space as well. You can of course do it with an O of 1 space by just using variables to keep track of the last fruit and the second to last one, right? So you keep track of, just for example here, 1 and 2, and for moving left you replace the second to last to be 2 and the last one to be 3. You could also do it that way, and that would be an O of 1 space solution. Yeah, so let's code this approach window 1 because it's simpler. So let's code it up and make sure it passes test cases. Okay, so let's implement this solution. So what we need first is we need a best count for just keeping track of the count so far, and then we need to do our left and right pointers, we also need, just to keep track of just to get the length, we need the window data structure. So this would be collections. I will use a counter. You could use a hash map as well. Should work the same way. And then we will go through the range of n go through all fruits. And then we will say fruits. We'll add each time we move right. Okay. And so when we add it, we just increment the counter for it. But we want to check if our window is no longer valid. And that means we will need to remove the left one, the leftmost one. And so if the length, this basically will check if we have more than 2 keys in the collection here. And that's exactly what we want, because we are allowed only 2 distinct keys. And so if it's bigger than 2, then we want to move the left side. So we want to say fruits left -1. And we also want to increment left. But we also want to do something here, which is if we reach it, if this became 0, we want to completely remove it, because we are using the length of the window keys. If we don't remove it, it will still be counted even though the value is 0. So we want to just, if it's equal to 0, we want to delete it so that it doesn't get counted towards the length of the window here. And so to do that, we'll just say fruits left and delete it like this. And this is a of1 operation. And then we will update our best count. So that would be just the max of the previous, whatever best count was before. And the new one, which is going to be just the window, the values in our window and the sum of those, right? Yeah, so let's say if we had 2 2s and 3 1s, for example, then it will just take the values, which are 2 and 3, and sum them up. Okay. And now we can just return best count. That should be it. So let's run it. Let's submit. And that passes our test cases. Okay. Yeah, so that's pretty much it for today's video. Please like and subscribe, and see you on the next one. Bye.